Okay.
Hello everyone, my name is Paparao. I am a mathematics teacher. So today I would like to explain one of the important lessons in 10th class mathematics, and that is surface areas and volumes. Surface areas and volumes. Actually, today we are going to learn problems which are in exercise 12.2. Basically, in surface areas and volumes lesson there are two exercises. How many exercises are there in surface areas and volumes lesson? There are two exercises are there in surface areas and volumes. Actually, this is the new syllabus of this is the new syllabus which is introduced by AP government for the academic year 2024 and 25. Actually, this is a new syllabus, right? Okay, let's solve the first problem in exercise 12.2. There are 8 problems in exercise 12.2. In this video, I will explain exercise 12.2 first problem, right? So first I will read the given problem and explain the meaning of the given problem, and later we will discuss the solution. A solid means a figure which has length, breadth and height is called three-dimensional figure. A figure which has length, breadth and height is called a three-dimensional figure. Actually, three-dimensional figures are, we know very well about three-dimensional figures. Cube is a three-dimensional figure, cuboid is a three-dimensional figure, cone is a three-dimensional figure, sphere is a three-dimensional figure, hemisphere is a three-dimensional figure, cylinder is a three-dimensional figure. So we have many three-dimensional figures in geometry. So three-dimensional figures are again classified into two types: solid figures and hollow figures. Solid figures and hollow figures. Here the given figure is solid. Solid means there is no space inside of the three-dimensional figure. For suppose, I will give you one example. If you see, this is a water bottle, right? Basically, the water bottle contains some gap inside. I mean, we can find some gap inside of the water bottle, right? Actually, currently the water bottle is filled with some water. If there is no water inside the water bottle, there is some space inside of the water bottle. So we can find some space inside of the water bottle. If there is some space inside of any three-dimensional figure, that figure is called hollow figure. How do we call that figure? Hollow. Hollow means nothing, empty. If the inside portion of the three-dimensional figure is empty, that figure is called hollow figure. Otherwise, that figure is called solid figure. I will give you some examples. If you observe water tank, the inside portion of the water tank is basically empty. Of course, the water, if you fill the tank with water, then it contains some water. So if there is no water in the water tank, that is empty. The inside portion of the water tank is empty. Basically, water tank is example of cylinder, right, Amma? So, but then what about the next one, marble? If you observe a marble, will you find any space inside of the marble? No, we cannot find any space inside of the marble. Marble is a sphere, right? Marble is example of solid figure. Then what about plastic ball? We know very well about plastic ball. Generally, we play with that ball. Generally, we play cricket with that ball. So, if you observe a plastic ball, there is nothing inside of the water in the plastic ball. Nothing means there is some gap inside of the plastic ball, but there is no gap inside of the marble. If you observe marble and plastic ball. What is the difference between these two? Actually, these two are three-dimensional figures because plastic ball is an example of sphere and a marble is an example of sphere. But the difference is marble is a solid figure, but plastic ball is a hollow figure because we can find some gap inside of the plastic ball. There is some space, there is some gap inside of the plastic ball. So the plastic ball is an example of hollow figure, but we cannot find any gap or space inside of the marble. So marble is an example of solid figure. I hope you understood the difference between hollow figure and a solid figure. But remember one thing, both hollow figure and solid figures are three-dimensional figures. Okay, ma? Right. Here one solid figure is given. This solid figure is in the shape of a cone. This solid figure is in the shape of a cone. This solid figure, what is the shape of the given solid figure? The solid figure is in the shape of a cone which is standing on a hemisphere. Here one more figure is given here. With both their radii being equal to 1 centimeter and the height of the cone is equal to its radius, find the volume of the given solid in terms of pi. Okay. First of all, I will explain the exact meaning of that. Is try to understand what is the exact meaning of the given problem. Basically, here one solid figure is given. Actually, the given solid figure is formed by combination of two solid figures. Right? What do we say about the given solid figure? The given solid figure is formed by combination of two solid figures. Here two solid figures will be given. The first solid figure is a cone and the second solid figure is hemisphere. The solid figure is in the shape of cone. This cone is standing on hemisphere. I will show the diagram. So here one hemisphere is given. We know very well about hemisphere. Half of the sphere is called hemisphere. What is the definition of hemisphere, ma? Half of the sphere is called hemisphere. So on hemisphere we have to take one cone. This is what? Cone. Right? This is the given solid figure. What is the shape of the given solid figure? The given solid figure is an example of combination of solid figures. What is the definition of combination of solid figures? A figure which is formed by two or more than two solid figures, that is called combination of solid figure. This is the example of combination of solid figure. Combination of solid figure. This is what, amma? Combination of solid figure. Combination, or what is combination of solid figure? Combination of solid figure means that figure will be formed by more than one 3D figures. If a figure is formed by more than one 3D figures, that figure is called combination of solid figure. If you observe a ice cube is not an example of combination of solid figure. Ice cube is just one figure, right, Amma? If you observe matchbox is an example of cuboid. It is formed by only one figure. But if you observe this toy, this solid will be formed by with the help of two figures. Here two figures involved in this figure. The first one is hemisphere, second one is cone. If a figure is formed by more than one solid figures, then it is called a combination of solid figure. So the given solid figure is formed by hemisphere and a cone. Okay. A solid is in the form of a cone standing on a hemisphere. So here one cone is given. The cone is, what is the position of cone? Where did we place this cone? We kept this cone on the hemisphere. So first we have to take one hemisphere. On hemisphere we have taken one cone. With both means two figures, hemisphere and cone. These two figures have same radii. The plural form of radius is radii. So hemisphere with here hemisphere and cone, both figures coincide with one another. So here we have placed cone on hemisphere. So here both figures have same radii. So the given hemisphere and cone have same radii equal to 1 centimeters. Amma, what is 1 centimeters, amma? 1 centimeters is the radius of hemisphere. At the same time, 1 centimeters is the radius of cone. I hope you understood this concept. Here, the given solid figure is formed by cone and hemisphere. The radius of cone and radius of hemisphere are equal. The radius of cone and hemisphere are equal to 1 centimeter. Clear, Amma? And the height of the cone is equal to its radius. Wow! See, Amma, if you want to find area or volume of solid figures, first we should know the measurements. Clear, Amma? Here one solid figure is given, Amma. This solid figure is formed by combination of two figures. First one is hemisphere and second one is cone. So here hemisphere measurement. Hemisphere has only one measurement. It requires only radius. Radius is given already. Radius of the hemisphere is 1 centimeter, Amma. But then what about second figure? One more figure is given here. That figure is cone. What about radius of the cone? Cone requires we need two measurements. We need two measurements to calculate area or volume of a cone. So those two measurements are given already. If you observe carefully, radius of the cone is given. The radius of the cone is 1 centimeters and its height is also given. The height of the cone is equal to its radius. So height is equal to radius. So what is radius actually? 1 centimeter. So height also 1 centimeters. Did we get the measurements of cone and hemisphere? Did we get measurements of both cone and hemisphere? Yes. The radius of hemisphere is 1 centimeter and the radius of cone is also 1 centimeter. The height of the cone is 1 centimeter. So what we have to find here? What do we find here? What will we find? Find the volume of the solid in terms of pi. So we have to find the volume of this solid. Very simple, Amma. If we want to find the volume of given solid, we have to find volumes of two figures. What do we find here? We have to find volume of given solid. So how will we find the volume of given solid? Very simple. There are two figures in the given solid. First figure name is cone and the second figure name is hemisphere. First we have to find the volume of cone and next we have to find the volume of hemisphere and finally we have to add volume of cone and hemisphere. If we add volume of cone and hemisphere, then we will get the volume of solid. Very simple. Okay, I hope you understood I hope you understood the concept. What will we find here? We have to find the volume of given solid figure. How will we find the volume of given solid figure? Very simple. There are two figures involved in the given solid figure. The first figure is cone and the second figure is hemisphere. So first we have to find the volume of cone and next we have to find volume of hemisphere. Clear, Amma? What is volume of cone, Amma? What is volume of cone formula? Volume of cone formula. What is the volume of cone formula actually? Okay. Volume. How do we get the volume of given solid? Volume of given solid. Volume of given solid is equal to volume of given solid is equal to, there are two figures involved in the given solid, right? First one, volume of cone and volume of hemisphere. Volume of hemisphere. Clear, Amma? First we have to find volume of cone and next we have to find volume of hemisphere and finally we have to add these two volumes. Then we will get the volume of solid. So what is volume of cone formula, Amma? Very simple, Amma. Volume of cone formula 1/3 pi r square h. Volume of cone formula is what? 1/3 pi r square h. Next write plus. Why? Because we have to add volume of cone and volume of hemisphere. Did you understand? Next, volume of hemisphere formula. What is volume of hemisphere formula? 2/3. 2/3. So volume of cone formula 1/3 pi r square h. And next volume of hemisphere. Actually, I want to find volume of cone, and next I will find the volume of hemisphere, and I will add two volumes. So first I have taken volume of cone. Volume of cone formula 1 by 3 pi r square h. And what is volume of hemisphere formula? Volume of hemisphere formula 2 by 3 pi r cube. Sorry, I am very sorry. 2 by 3 pi r cube. 2 by 3 pi r cube. I am very sorry. Volume of hemisphere formula 2 by 3 pi r cube. Okay. First I will find the common terms. Actually, is it expression or not? 1 by 3 pi r square h is a first term. 2 by 3 pi r cube is a second term. Right. First I will find the common terms in volume of cone and volume of hemisphere. What are common here? Pi common. First one. Pi. Okay. First I will expand it. You can understand easily. You will understand. 1 by 3 into pi means here we do not write pi value. Why? Because we have to find the answer in terms of pi. So we have to show the answer in terms of pi. So we do not take the value of pi 22 by 7 or 3.14. We do not write pi value. Right, because we have to show the answer in terms of pi. We will show the answer in terms of pi. Answer must have pi. So I don't take 22 by 7 or 3.14 instead of pi. I will write pi as it is. R square means expand r square, r into r into h plus 2 by 3 into pi r cube means r repeats 3 times, r into r. Now identify the common terms here. What are common terms here? 3 common. I mean 1 by 3 common. 1 by 3 common. So first take 1 by 3. 1 by 3 is common. Next pi common. 1 by 3 into pi common. Radius same actually. Cone radius, hemisphere radius same. So r common into r. Again one more r is there. R common into r. Right? Now write the remaining terms. Here what are common? What are the common terms in volume of cone and volume of hemisphere? 1 by 3 common. Pi common. R common. So write the remaining terms. Here in volume of cone, which one is left? We have taken 1 by 3 is common, pi is common, r is common. So h is left, right? H plus here. Next in volume of hemisphere, which one is left? What are the remaining terms? Already 3 common. So 1 by 3 is common. So which one is left? 2. 2 by 3 means what, How can we write 2 by 3? 2 by 3 means 2 into 1 by 3. Can we write 2 by 3 as 2 into 1 by 3? Yes, 2 by 3 means 2 into 1 by 3. So already 1 by 3 is common. We have taken 1 by 3 as common. So which one is left? 2. 2 by 3. What? Already we have taken 1 by 3 from 2 by 3. Already we have taken 1 by 3 as common. So which one is left? I will give you very good example. 2 by 3. 2 by 3 means how will we write 2 by 3? 2 into 1 by 3. Next 3 by 5. How will we write 3 by 5? Very simple. First write numerator 3 into 1 by 5. How will we write 5 by 8? Very simple. First write numerator 5. Next 5 into 1 by 8. Clear? Already 1 by 3 is common. So next which one is left? 2 is left. Pi already we have taken common. R already common. R common. One more R is there. H plus 2R. Next I will substitute values. 1 by 3, 1 by 3. Once again I am telling you, we do not write 22 by 7 instead of pi. Because we have to show the answer in terms of pi. What is the question? Find the volume of solid in terms of pi. So we do not take pi value. We directly write pi value. I will write pi value directly into r means what? Radius. Radius of hemisphere. R radius of hemisphere is given 1 into what is r? Radius of hemisphere or radius of cone. Both are same. Radius of cone and radius of hemisphere are same. Both figures have same radii. Into h means height of the cone. What is height of the cone? Height of the cone is also equal to radius of the hemisphere. That is 1 plus 2r means 2 into r. R value, r means radius. Radius is 1. According to BODMAS rule, first we solve bracket values. 1 by 3 into pi into 1 into 1 into 1 plus 2 ones are 2. First I will solve bracket values. 1 by 3 into pi into 1 into 1 into 1 plus 2, 3. Clear, amma? Next I will multiply all these terms. Write by 1, by 1, by 1. 1 into pi, pi. Pi into 1, pi. Pi into 3, 3 pi. 3 pi. By 3 ones are 3. 3 ones are 3. 3 ones are 3. 3 pi by 3. 3 cancel. So what is the answer? The answer is also pi. So what is the volume of the given solid? The volume of the given solid is also pi. So what are the units of volume? Units cube. So units are what here? Centimeters. So the answer is pi centimeter cube. So what is the volume of the given solid, amma? The volume of the given solid is pi centimeter cube. Very simple, amma. Here one solid figure is given. This solid figure is formed by hemisphere and cone. So here hemisphere and cone both are coincide with one another. Both are coincide with one another. So here radius of the hemisphere and radius of the cone are same. So what is radius of the hemisphere? Radius of the hemisphere is 1 centimeters and radius of the cone is 1 centimeter. And height of the cone is also given. What about height of the cone? What did he say in problem? In the problem, he said that height of the cone is equal to radius. So, if here radius is 1 centimeter, so height is also 1 centimeter. The question is, find the volume of the solid in terms of pi. So, we have to show the answer in terms of pi. Very simple. To find volume of given solid, first I will write volume of cone formula plus volume of hemisphere. I added volume of cone and volume of hemisphere. First I wrote volume of cone formula. Volume of cone formula 1 by 3 pi r square h plus volume of hemisphere formula 2 by 3 pi r cube. Amma, here before I want to add volume of cone and volume of hemisphere. First, I want to take common terms. I want to take terms which are common in volume of cone and volume of hemisphere. Amma, what are the common terms in volume of cone and volume of hemisphere? Very simple, amma. 1 by 3, 2 by 3. 1 by 3 is in fraction form, 2 by 3 is in fraction form. So 1 by 3. In 2 by 3, we can find 1 by 3. 2 by 3 means what, amma? 2 by 3 means 2 into 1 by 3. So, can we find 1 by 3 as common? Yes. So, I have taken 1 by 3. I have taken 1 by 3. 1 by 3 from both terms. So, here 1 by 3 and 1 by 3 are common. Next, pi. In volume of cone formula, pi is there. In volume of hemisphere formula, pi is there. So, pi is common. R square means what, I expanded here. R square means R into R. R cube means R into R into R. So what are common terms here, amma? 1 by 3 common, amma. Pi common, amma. R common, amma. Again R common, amma. So what are left here? H and 2R. So H plus 2R. Next I substituted values and I solved bracket values and I got the answer. 1 by 3 into pi into r into h plus 2r. 1 by 3 into pi value we did. So here I didn't write pi value here. Pi is pi, r value 1 into h value 1 plus 2r, 2 into 1, 2 into r value 1, Here radius is 1 centimeter ma. Hemisphere radius is 1, cone radius is also 1. So 1 1. H height is also 1 1 plus 2 into r means 1. First I solved bracket values. 1 plus 2 ones are 2. Next I added bracket values. 1 plus 2 3. Next I multiplied them. 1 into pi pi into 1 pi into 1 pi into 3 3 pi by I multiplied denominators. 3 ones are 3 3 ones are 3 3 ones are 3 by 3 3 pi by 3 3 gets cancelled. The answer is pi. So units centimeter cube. So what is the volume of the given solid figure? Pi centimeter cube. I hope you understood. I hope you understood this problem very well, and thank you very much. Have a nice day.